Check. Good afternoon, everyone. I'm Shanmugam, a program manager with the Remote Desktop Virtualization team. My team, part of Windows Server organization, is responsible for building and delivering RemoteFX technologies as part of Windows 8 and Windows Server 2012. So the topic for this session is understanding RemoteFX technology in Windows 8 and how it enables you to centrally deploy applications and deliver it to your end users, irrespective of where they are and how they want to access their applications. Be it users on corporate LAN networks, or users that want to work from home, or users that want to bring in their own Windows RT-based devices to work and expect to be as productive as they are with their regular PCs. In terms of agenda, I want to walk through the specific capabilities that are part of RemoteFX and explain how each of those come together to deliver a very rich experience for end users. My goal is to talk less and show more demos so that you get a first-hand experience of what the end user experience is going to be like when they use RemoteFX to access their work applications. If there's one key takeaway that I want you to walk away this room with, that is going to be the fact that RemoteFX in Windows 8 enables a fast, fluid, and seamless experience for end users for accessing their work applications. A quick show of hands, who here is familiar with how Remote Desktop Protocol has evolved over the multiple Windows releases? Fair enough, there are a few in the audience that are familiar with RDP. So let me start with a quick overview of what has happened in the past, what are the capabilities that Windows 7 and Windows 7 SP1 introduced in the remoting space, before we go into the details of what is new in Windows 8. The version of the protocol that shipped in Windows 7 was Remote Desktop Protocol 7.0. It introduced significant new capabilities for the remote experience, including features such as media redirection, which enabled a very rich client decode-based experience for Windows media content. Windows 7 also introduced true multi-monitor support. End users can use multiple monitors on the client side and work with their remote applications and desktops. Windows 7 also introduced true Aero Glass experience support, whereby users can use all of the Aero experience features with their remote desktop sessions. SP1 improved on what was delivered as part of the Windows 7 release. The 7.1 version of the protocol also integrated certain technologies that we acquired as part of the Callista acquisition. A significant part of that release was about enabling a virtualized GPU experience for Hyper-V-based VDI scenarios. SP1, in summary, enabled users on corporate LAN networks to have a very seamless experience, both with and without RemoteFX virtual GPU. Now, with that context, let's switch over to Windows 8. While Windows 7 and the SP1 release was about enabling a seamless experience for LAN users, Windows 8 is about three things. One, delivering the same rich, local-like experience for users on WAN networks. Two, it's about bridging the local experience and the remote experience, making it seamless for users to be able to use their remote applications with their local devices and have the same sign-on experience. Specifically, things like multi-touch, single sign-on, etc., make the bridge between the local experience and remote experience disappear. The third key scenario that Windows 8 or RemoteFX in Windows 8 enables is the fact that it enables a multitude of deployment options for customers. You could have the traditional terminal server or remote desktop session host workload and deliver the same rich experience. If the workload demands it, you could have VDI deployments with the default inbox software GPU that provides basic graphics acceleration. If you have applications that demand a GPU, you can have RemoteFX virtualized GPU and still deliver the same experience for both users on corporate LAN environments and WAN networks. Let's now go into the details of each of these features and look at demos that will substantiate the experience that end users get. So before I move on, for some of you that are familiar with RDP and how we've branded certain features, in 7.1 release, our remote desktop protocol was the display remoting protocol. RemoteFX referred to the specific capabilities in the protocol that enabled virtual GPU, as well as encoding for natural image content. In Windows 8, RemoteFX is part of the core protocol. RemoteFX is enabled and available for all endpoints, including when you're connecting to another physical PC, when you're connecting to a remote desktop session host server deployment, or when you're connecting to a VDI deployment. Now, with that introduction, I want to move on to the IT provisioned application scenario and talk about the end user experience with accessing IT provided apps. What I'll do is, since there aren't a lot of folks that are familiar with the past capabilities, I'm going to switch over to the demo. I'm going to walk through the user experience first, and then come back to the slides and then summarize the key points. Okay, my demo machine is up. So for this scenario, imagine that I'm a user with a typical enterprise. I went out and got a Windows RT-based Surface device. The Surface device was great at home last evening for personal work. I was able to email with the touch keyboard. I was able to consume media content, Netflix, Hulu, everything else. But then I'm back at work today. I want to be able to use this device. I want to be able to be as productive as I am with my regular x86 or x64-based PC. To do that, I need access to not only the standard suite of productivity applications, but also some of the line of business applications that my corporate IT has provided me with. How do I do that? Let's see that in action. So as a user, all I need to do is go to the Windows Store remote desktop application. If the application is not pre-installed, I could go to the Windows Store and install it just as I can install any other store-based application. So what you see here is what we call as the day zero home screen experience. Right? It provides me a intuitive, clutter-free interface on day zero, and then it tells me if I want to access work apps, click on the following link. So once I click on that, I'm asked to key in my email address. Let me do that and see what happens. All right, I've typed in my corporate email address. I'm going to say connect. So what has happened in the backend is the application, based on DNS discovery, auto-discovered the servers that the administrator has centrally deployed and published applications from. For those of you that are familiar with the backend server architecture, so what is happening is the client application is talking to the remote desktop web access component, which acts as a single point which aggregates all applications, and then based on the user that is connecting in, determines what apps he or she has access to. So let me say yes on this. So it then asks me to provide my credentials. That's because I'm on a Windows RT device that is not joined to the domain. So I need to authenticate to the remote desktop web access server with my credentials once. Let me go ahead and do that. I'm going to say OK. So what is happening is the web access server has authenticated me. It then at the back end talk to the brokering component that is part of the remote desktop connection broker to determine what are the desktops and applications that the IT administrator has published for me. So it says I've got access to 3 desktops and 22 apps. Let me say OK. So now what has happened is the application has pulled down the application manifests for the remote applications, and I can see all the applications that the IT administrator has made available. I can see that I have three different desktops available. I also have a bunch of regular Win32 applications that the administrator has published. There is no restriction on what applications that the administrator would be able to publish for me. It could be any regular Windows 32 application that runs on a Windows desktop. The applications are not only available in the remote desktop's home screen, but also I can go to the start screen, and all the applications are seamlessly available in the start screen of the Windows 8 desktop. So if I'm a user, I don't need to go to the remote desktop application every time to launch apps that the IT has provided me with. I could just go to the remote desktop app once, subscribe to the applications with my email ID, and then I can go back to the start screen every time that I want to launch an application. Now let's go ahead and tap on one of these applications and then see what happens. So the very first time I launch an application, what is happening is the client application talks to the broker component in the backend first. There's a bunch of orchestration that happens in the backend to spin up a new VM or a new server based on the deployment configurations. If there is a session already running, I'm connected to it. Otherwise, a new session is spun up in the data center. The application is launched, and the application's display alone is being remoted to the client side. From the user side, there is no difference in working with this application versus an application that is installed and running locally. To be clear, what you see here is a Windows Word application that is running in the data center, but the display part alone is streamed to the client side. I could launch multiple applications. It's not just limited to one application. I can launch any number of applications. These applications are integrated with the local desktop. By that I mean these work seamlessly with other local applications. For example, I could copy content. I'd say this is a local app. I can copy this content back to the remote application. I can copy content between the applications that are running remotely. Right, from the user perspective, the experience is as seamless as it can get. Let me copy this again. For some reason, that doesn't seem to work, but demo gods are not with me. Anyway, so the other point that I want to talk about in the local desktop integration is the fact that I can also use the local machine's language switcher. Right? Language switcher is the user interface that users are familiar with on the client side, local desktop side to switch between languages. I could use the local language bar, for example, to switch the language that I use to interact with the remote application as well. So from a user perspective, there is no difference between this and any other application that is running locally. Even things like the taskbar icon are that of the remote applications icon. Go ahead.
You can access the file system of the local device?
You can access the file system of the local device as well, yes.
Word document to the local machine?
You can do that, yeah. So this is one. The other feature that I wanted to talk about was, so what happens at the end of the day, right? So you want to close the lid of your laptop or power off your device. You want to go back home and then reconnect to all your applications. In the past releases, the user experience was pretty cumbersome. I had to save all the applications, save the state of those. If I'm working on a Word document, I had to save the file, and then I close the applications. I go back home, launch all the different applications one by one. Windows 8 makes it super seamless. What I can do is, I'm going to switch the language bar back to English before the other demo. So what I can do is I can not reconnect, I'll have to say disconnect. Right? Disconnect simulates the action of just closing the lid or powering off the device or going off the network. I'm now back home. I want to reconnect to my work applications. I don't want to go hunt each of the applications and then launch them one by one. What I can do is go to the workspace icon and then say I want to reconnect to my work applications. So once I reconnect to my work applications, all the applications are presented back to me with the same state that they were in when I left work. There's no data loss whatsoever. These applications are running in a secure environment in the data center, so the state is retained as they were. There's no loss in data. Good. So I'll take that question, but I'll also ask you to hold your questions towards the end so that we can get through the content and then we can open up for Q&A towards the end. But go ahead. So the question was, what happens when I leave work? Leave work, I'm at home. I don't have access to port 3389 of the deployment servers. So Remote Desktop Services has a component called Remote Desktop Gateway. which you deploy on the edge, which enables a HTTPS-based mechanism for your clients on the internet to get to your intranet servers. It's very similar to how Outlook works over HTTPS for extranet connections. So that's a very secure channel. Your clients talk to the gateway server then channels the connections back to your deployment servers that are running applications or desktops. Anyway, so with that, let's switch back to the PowerPoint. Right, so we talked about how Windows 8 makes it seamless for end users to, just with their email ID, get access to work resources. They could get access to their work resources even on a Windows RT-based device that can't natively run those applications locally. There is no user training involved. All they need to do is key in their email ID, which you would expect everyone to know, and then get access to all their applications and get productive right off the bat. The applications, as I showed you, are integrated with the start screen. Users don't need to hunt for applications. There's no separate place that they need to go to access their work applications. The other point that I didn't stress during the demo was that, if you had noticed, you would have seen that there was only once that I entered my credentials. That was during when I subscribed to the applications. So after that, even though I'm on a non-domain joined Windows RT device, logged in locally with my live ID credentials, I didn't have to key in my username password, both for launching applications as well as after going back home and reconnecting to the work resources. So the end user experience is as seamless as possible. I key in my credentials once, and after that I don't need to key in my credentials again unless the credentials are expired or I've changed the password. The other part about the remote app experience itself, it integrates remote applications with the local desktop. You've got taskbar integration, language bar, and things like that. Make it the best possible way to deliver classic applications to Windows RT-based devices and users on those devices. Now, so that is one part of the experience, and how RemoteFX in Windows 8 makes it easier for end users to access apps, run them, how they are integrated well with the local desktop. But the other question is, what about the interactive experience that the users can have with these applications? One of the questions that I get asked very often is, look, these applications are running in a remote data center. What is the level of user experience? Can users have the same level of rich experience that my application is designed to deliver for local users? Let's now understand how. Windows 8 builds on the capabilities of Windows 7 and then delivers a very rich experience both in terms of graphics experience as well as in terms of the interactive experience that end users can have with their remote desktops and applications. Specifically, there's been a lot of investment in making sure the touch experience is consistent between the local and remote desktop. You have full fidelity multi-touch remoting. There's also gesture remoting built in. There's no, unlike in Windows 7 where there was touch to mouse translation, Windows 8 supports native touch remoting. That means you could have your application centrally deployed. Users can use multi-touch input as well as gesture remoting to work with their applications. The remote desktop app UI itself, as I showed earlier, is designed for touch input. It is designed to be fat finger friendly. There are also other nice enhancements like the touch pointer feature, which makes it easier for end users to work with applications that are not really designed for touch. I'll talk about that during the demo part. So that is on the touch side. On the graphics side, RemoteFX in Windows 8, in fact, introduces a whole new architecture for efficiently remoting graphics content. There are a number of new techniques in Windows 8, including things like adaptive encoding, multi-codec encoding schemes, progressive rendering, etc., that make it easier to deliver a very rich experience, irrespective of where the users are on or what type of devices that they are using. This is a very high-level conceptual architecture of the graphics remoting system. It's not a design diagram as such and doesn't capture all the pieces of the remoting architecture. but at a high level shows how the RemoteFX system is layered so that the local-like experience that I've been stressing for so long can be delivered to end users. The primary goal of the remoting system is to take the Windows 8 desktop app and application experience and package it in a manner that can be delivered seamlessly to end users on LAN networks, WAN networks, or users that are on a lossy network or a low bandwidth network. RemoteFX in Windows 8 improves on some of the techniques that are present in Windows 7, things like the RemoteFX intelligent caching scheme. It also introduces a bunch of new techniques like RemoteFX media streaming, RemoteFX progressive rendering. There are also new codecs that Windows 8 introduces that are optimized for specific use cases. I'll talk a little bit about that in the subsequent slides. The other key part of the Windows 8 remoting system is what we call as the RemoteFX or WAN. RemoteFX for WAN stands for all the transport level enhancements and new transport mechanisms that are built to deliver the Windows 8 experience. I'll talk about that as well. So the key takeaway from the architecture is, so the RemoteFX system in Windows 8 is designed so that it can dynamically sense and adapt to changing network and application characteristics. You don't have the same workload or the same network configuration for all users or at all the time. Users are going to be using different applications from different network types. Your load on the server is going to be different. So a key design goal for Windows 8 has been to make sure that RemoteFX can dynamically sense all these parameters and then dynamically fine-tune the delivery of the remoting experience to end users. So one of the techniques that I want to touch upon a little bit is what we call as the adaptive graphics technique. So for those of you that are familiar with codec development, it might be known fact that most codecs, if not all codecs, are optimized for one type of content. For example, you have codecs that are designed for video delivery over the internet, which do a pretty good job about encoding video content. On the other hand, you have codecs that are designed for text content or static images like JPEG codec, which are super optimized for that scenario. The challenge with Windows desktop remoting and application remoting is the fact that you've got different types of content in a Windows desktop. So RemoteFX addresses that issue by using a multi-codec encoding scheme. What it does is it uses pretty smart frame inspection algorithms to determine the different types of content that make up a specific. I should be using this. That make up the desktop frame. For example, it identifies the text regions of the screen, so that a codec that is highly optimized for text content can be used to encode those regions of the screen. It also identifies image content. There are two types of image content: natural images and what we call as synthetic images. Synthetic images are basically computer rendered images. And then it also identifies videos and animations. The advantage of this scheme is that now you can use a codec that is highly optimized for that specific content type, and also you could use slightly modified delivery parameters for each type of content. For example, if it is video or animations, then you would rather optimize for frame rate than for frame fidelity. On the other hand, if it is text, then I would rather optimize for fidelity of the text that is delivered to the users than frame rate. So the other scheme that RemoteFX uses is RemoteFX progressive rendering. Most of you are familiar with progressive rendering. Progressive rendering basically enables RemoteFX to deliver a low quality or low fidelity frame first, and then progressively render the quality of the frame if the user stays back at the same content without doing things like flipping over pages or scrolling the content. The advantage of this is users have a very high perceived frame rate, and when user stops at a specific content, either to read that or do a closer inspection of the screen content, the quality of the frame is progressively refined so that end user experience is not compromised by delivering a low quality image first. But unlike some of the other progressive rendering schemes, the key difference is since RemoteFX has the screen content detection algorithm that we talked about earlier, it is able to ensure that only text content, only the image content is degraded in quality. The text content of the screen stays as sharp as possible. So if, let's say, for example, user is scrolling through a PDF document, the text always remains sharp. Let's see. Okay, so with that, let's now look at a demo of some of the features that I talked about. Okay, got it. So let's start with a brief walkthrough of the remote desktop application. I briefly touched upon it in the earlier demo. So this is, as I said earlier, this is the new remote desktop application that is available in the Windows Store. Users could just download it and install it. Of course, the most important functionality of this application is for users to be able to go subscribe to their work resources. For advanced users, I can also type in the name of the server, connect to a particular. For example, if you're a developer, you want to connect to your PC for debugging for other reasons, I could do that. Or if I'm a user that wants to get access to my IT provided desktops, I could just simply tap on a desktop icon here and get connected to the application, a remote desktop. The application also for advanced users, there are a bunch of settings that are exposed in the settings bar. I could choose what devices, what local devices are available to the remote sessions. There was a question earlier about, are local devices, including file system, available? Yes, they are available, and you can also control what local devices available to the applications that are running in the data center. I can control whether printers are redirected and available. I can control whether the local clipboard is available. Things like smart card, microphone. Do I need to have audio or not? Similarly, the remote desktop gateway aspect that I talked about, where if I'm coming from the extranet, I can specify the remote desktop gateway server to connect back to my PC that is within the corporate firewall. But again, to be clear, these settings are for the advanced users. End users don't need to care about it. All these settings are part of the application manifest that the IT administrator publishes. So each of the application manifests that you see here internally has all these policies that the admin has defined for the end users. So end users don't need to care about what gateway server I need to use or what specific settings are allowed by the IT administrator or not. That's all pre-built into the application manifests that are pushed down from the server side. All I need to do is just tap on these and then get connected as an end user. Let's now connect to a remote PC and then see what the experience is like. Touch, is that thing? No. So what I did was there was a address bar at the bottom. I keyed in the name of the server that I want to, or a PC that I want to connect to, and I did connect. It should go through. So one tricky issue is some of my the demo setup is in a private domain, but this machine is joined to the corporate LAN, so I think there's a DNS issue where it takes a while to figure out the name, do the appropriate DNS name resolution. So here I am, right? So I'm connected to my remote PC. As expected, I have a full screen experience except for the tiny little remote connection bar at the top that comes up that reminds me that I'm in a remote session. I can tap on that. If I want to pull down what we call as the application bar, clicking inside the session again dismisses that. I have a full screen experience. Let's go back to the application bar. And so the application bar is designed very similar to what you would see on IE, at least the top part of the application bar. It has a very, very, very similar tab style interface to that of IE. If I have more than one connection open, I could just tab between the live tiles that are up there, and then I can switch between multiple sessions. At the bottom are so some of the most commonly used functionality. For example, there's the home button, which if I were to tap on it, it'll take me back to the home screen. If I have to launch a new desktop or type in a name of a different server and then connect to it, I could do that by going back to the home screen. The next one is what we call as the connection bar. This brings up information about your connection characteristics. I'll talk a little more about it in the subsequent part of the demo, but this is especially useful for the help desk when they're troubleshooting performance issues that end users report. There's basic information displayed here, which help desk can use to determine what the cause of a poor experience is. There are more advanced counters that are available in the performance counter UI. So IT, when they're troubleshooting performance problems, could look at those counters and determine what the root cause of the problem is. There are a few other functions on the other side. Things like you can launch the remote machine's start screen. You can switch between applications. You can invoke the remote applications app command. You can also invoke the remote machine's charm command. So one of the aspects that I talked about earlier was what we call as the touch pointer functionality. So what touch pointer does is it's not going to be uncommon for end users to be in a situation where they are using a device that is designed for touch, like the Surface device, but then they're allowed to work with an application or a line of business application that was designed probably 5-10 years back, which is not really designed for multi-touch input or fat fingers. So touch pointer enables users, or at least makes it a little more easier for users to work with such applications. So what touch pointer does is it turns the entire screen into a virtual trackpad. Let me explain what happens, right? Maybe that's not clear. Let me launch an application like, for example, WordPad, right? Which, if I were to be honest, it is not really something that is designed for touch input, right? But let me go turn on touch pointer, right? What it allows me to do is use the entire screen as a virtual trackpad. So as you can see, I haven't turned on my touch echo. So what is happening is the pointer moves in accordance with where my fingers are. I can use the entire touch surface as a virtual trackpad, and use my I can use the finger that is on the left side of the finger that is that is controlling the pointer. Use that to tap on a UI aspect to simulate left click. I can also do right click. So that way it is very similar to having a huge trackpad to work with those applications. Right? So imagine it's slightly harder on a regular laptop, but if you're on a Surface device that is on your lap, if you want to work with an application that is really designed for mouse, you could still use the virtual trackpad functionality to work with those applications seamlessly. Now, anyway, so that's about touch. Right? Now let's look at the graphics experience. I talked about RemoteFX adaptive graphics, how it uses content detection to use the appropriate encoding schemes, how it uses progressive rendering. Let's look at some applications that will sort of demonstrate the experience that end users can have with RemoteFX. Some of you might be familiar with the Globe application. It is part of the Touch Pack for Windows 7. It's an application that is built to demonstrate touch. If I could get it, what I need to do is it's still in the touch pointer mode, so I'm going to disable that. Since this is a true application that is designed for touch, I don't need the touch pointer functionality anymore. So as you can see, this is an application that is running in the remote system. I'm using two of my fingers to zoom in, zoom out, pan, rotate. I can basically use all gestures that the application supports locally. Right? It's not just about touch. Though this application is running in a remote machine, there's actually a virtual machine that is running in a Hyper-V setup back in my office. There is no graphics card or whatever. It's just using the in-box software GPU. I can still, as an end user, get the same full fidelity experience that I would typically expect if the application were running locally. Right? Let me close this. Let me launch another impressive TouchPack application. So this was a screensaver app that was part of the TouchPack as well. This is a full screen app, right? Though this is a remote machine that's running back in a different data center, there's network latency, there's processing limitation on this being a VM, there's no GPU, but you could still see the extent to which RemoteFX can deliver a full fidelity experience. What is not visible is the fact that that is the multi-codec encoding scheme that is at play here. That is progressive rendering that is being applied here. There is the various transport optimizations that I talked about that are being used here. Right? You could To remind you, we are still in a remote session, right? This is a remote session. So if I tap on this, that will bring up. It's still running in remote session. I have full fidelity experience. Now, that was some of the Windows 7 era applications, right? What about some of the new Windows 8 style applications? Let me go to the start screen of the remote desktop. It's a virtual machine actually, so it's a VDI virtual desktop. Here's the start screen. I can work with it. The experience is seamless. Let me go ahead and launch. Let me see. Let me launch Fruit Ninja, right? That way I can demonstrate touch as well as graphics. Let me reduce the volume a little bit. It's a new game. This is all running in a remote session, by the way. There is no GPU present in the virtual desktop. There's just a software-based GPU, or what is called Warp. I can work with these applications. I can use touch. The graphics is seamless. There is very good touch input versus graphics coordination. What would happen is if there was any latency, or how do I go back? No, retry. If there is latency between touch input versus graphics, then I would not be able to swipe and cut the fruits. The fact that I'm able to accurately slice the fruits indicates that there is very good touch input to graphics coordination there. Anyway, let me close that. Let's go back to these slides. So that sort of shows the multi-touch and graphics capabilities. Now let me go on to the next section and talk about the WAN experience. So what do we mean by WAN, right? So for us, WAN is characterized by three aspects. One, it's a low bandwidth, constrained bandwidth network where you don't have as much bandwidth as is typically available in a LAN network. Your bandwidth might be as limited as 756 kbps for a connection between your client and server. The other fact about WAN networks is the fact that the end-to-end latency is quite high. In a typical corporate LAN network, the latency is anywhere between, it's usually less than 5 milliseconds, but in some networks you might see a range between 5 to 10 milliseconds. Whereas in a WAN network, you could see latencies of as high as 200, 250 milliseconds. The other part about WAN networks is the loss. While you rarely see loss in a LAN network, in a WAN network you could see loss rate of as high as 1% or 2%. Now, if that fact is further complicated, if you have users that are on a 3G device that is connecting using 3G network, then you're going to have even more loss. So for us, the challenge is to design a system that can sense these varying network characteristics and parameters, and then fine-tune or adapt its internal algorithms so that an optimal experience can be delivered. Right? There are a whole host of new techniques that are implemented in Windows 8, specifically in the RemoteFX WAN transport layer. But I want to touch upon some of the key aspects that we think are foundational to the RemoteFX for WAN feature. One is the fact that unlike Remote Desktop 7, which was a purely TCP-based protocol, RemoteFX in Windows 8 can intelligently choose between UDP transport and a transport that is based on TCP. For those of you that are familiar with transport protocols, know that UDP is very well suited for real-time delivery, but offers no guaranteed delivery. TCP, on the other hand, offers guaranteed delivery, but then it is not very well suited for real-time delivery, specifically if you are in a high latency or high loss network. So what RemoteFX does is intelligently, based on the content type, based on the characteristics of the network, intelligently chooses between sending content over UDP versus TCP. It also has some sophisticated loss recovery algorithms that are built on top of UDP, so that even if there's a packet loss, it could recover from that. So the other technique that goes hand in hand with being able to use two different types of transports is what we call as the network auto detect. So what RemoteFX does is continuously estimates what the characteristics of the network is. It detects what the end-to-end bandwidth is and what the pipe can hold. It detects what the round-trip latency is. It also detects what the loss rate is. Now, knowing that not only helps the multi-transport layer to fine-tune things like buffers and other send rate, etc. It also provides that feedback back to the upper layers like the adaptive graphics layer, the encoding layer, the media streaming layer, etc. So that those layers can make appropriate adjustments in their encoding scheme, so to better suit the network condition. For example, if you detect that you're in a lossy network, the adaptive graphics can fail over to a codec that is loss resistant. Right? On the other hand, if you're not on a lossy network, you don't need to use a loss resistant codec. So, but at the end, the goal of all that is to deliver the same localized rich experience that your LAN users can have for users that are on things like branch offices, or users that might be using wireless devices, users that want to work from home, etc. The other aspect that I briefly touched upon is RemoteFX media streaming. Most of you that have implemented client-server systems would know that irrespective of how good your transport layer is, if you have someone that is pumping in a lot of content, loads and loads of data, your transport system is not going to be able to handle that. One typical scenario where you might run into a similar case is where a user is logged in remotely and watching a media content. Let's say he's on YouTube watching an HTML5 video. Right, so what RemoteFX in Windows 8 does for those cases is it has content detection schemes that are running on the server side that continuously inspect all the incoming frames from applications and determines when there is a video application that is running. It does that by doing a combination of things. It looks at pattern of screen content. It has a heat map based algorithm. It has certain heuristics built in as well. But the end result is it is able to identify that there is in fact a video that is played back in the remote side. Now, once you figured out that there is video content for in a specific rectangle of the frame, what you can do is use codecs that are highly optimized for video delivery. You can also prioritize frame rate over frame fidelity, since it's a video application. RemoteFX specifically uses H.264 and AAC codec, which is the predominant codecs for delivery of media content over the internet as well. The problem of delivering media over internet shares some of the characteristics with delivering it over RemoteFX. You've got high latency connections, high loss connections, limited bandwidth. Now, the end result of that is phenomenal, right? Comparing RDP 7 in Windows 7 versus RemoteFX in Windows 8, there is up to a 90% drop in bandwidth usage for the video application scenario. I'll show that in a demo in a little bit, but thanks to the content detection schemes and using a highly optimized codec, RemoteFX can now deliver up to 90% in bandwidth savings. There is a feature called Windows Media Redirection in Windows 7 that is still retained. If you're on a corporate LAN network, Windows Media Redirection provides a better user experience because that natively redirects the bit stream to the client side. There is no decoding and rendering that is happening on the server side. There's a pure redirection happening. The client decodes the video and then renders it. That way, you not only save on bandwidth, but also on the processing power on the server side. You could have a higher scale with Windows Media Redirection in effect. Okay, so let's now switch over to a demo, and I can walk you through some of the points that I was talking about. Okay, so what I'm going to do for the first demo is I'm going to demo content build. So what I'm going to do is I'm going to launch 2 remote desktop sessions to VDI desktops that are running back in my setup in the office. So I'm going to connect to a Windows 7 virtual desktop and a Windows 8 virtual desktop. Okay, so the one on the left side is a Windows 7 virtual desktop. The other one is a Windows 8 based virtual desktop. So the client is a Windows 8 system, so the connection to the Windows 8 desktop is using RemoteFX. On the other hand, the connection to the Windows 7 desktop is using RDP 7. So what I'm going to do is I'm going to start, let me mute audio on the one side so that we don't have 2 conflicting streams of audio coming down. So what I'm going to do is launch the video on this Windows 7 side. I'll then launch the same video on the Windows 8 side. By the way, to clarify, this connection is on a pure LAN network. What I want to demonstrate now is that though the experience is very similar, right? There is very little difference in experience between Windows 7 and Windows 8. Windows 7 was designed for LAN environments. Windows 8 is able to deliver the same experience. But what I want to highlight now is, let's go to the Task Manager and look at the bandwidth usage. Let me go to the Performance tab. Click on Ethernet. You can see that the receive rate is between 35 to 50 Mbps. That's the total receive rate that the client is receiving from both these connections. So that's the aggregate. That's the total, right? Now let's do this. Let's go ahead and stop the Windows 7 video, and then see what happens, right? So what you can see is you had an aggregate bandwidth. Earlier you had an aggregate bandwidth usage of around 45 Mbps. The minute I start the Windows 7 video, the total bandwidth usage only for the Windows 8 connection came down to around, it is between 4 to 7 Mbps. Now what does that tell us, right? It basically tells us that of the earlier total 45 Mbps, Windows 8 was taking up around 5 to 7 Mbps, whereas the Windows 7 case was taking up to between 35 to 40 Mbps. So that's what I mean by up to 90% of bandwidth savings. So to stress, this is on a LAN environment. I have two very similar connections. These are two virtual desktops that are running in the Hyper-V server. Everything is same except for the fact that one is using RemoteFX in Windows 8, the other is using the RDP 7.0 protocol. Now, so this is about LAN. This is about bandwidth usage on the LAN, right? But let's now see whether the bandwidth savings translate to better experience on WAN networks. So what I'm going to do is, I'm going to again launch connections to two virtual desktops. One is a Windows 7 virtual desktop. The other is a Windows 8 virtual desktop. The only difference between this and the previous case was the fact that these were supposed to be running a network emulator. Let me do that. Let me start the emulator. So I've configured both these virtual desktops with an emulator that restricts the bandwidth or that modifies the network characteristics to emulate a WAN connection. I've limited the total bandwidth to less than 2 Mbps. There is a round trip latency of around 200 milliseconds introduced. There is also 1% packet loss. So let's do this. Let's first start the video on. Let's make sure the emulator is running. Let me start that. I've started it on both the machines. Okay, so let's do this. Let's first go launch the same video that we saw earlier, first on the Windows 7 case. I'm going to mute the audio because audio is going to be horrible. Right, so this is the experience that a user on a WAN network gets with Windows 7, primarily because you had the protocol pumping in as much as 40 Mbps of data, but you're on a constrained network where the bandwidth is only 2 Mbps. This is the experience that can be delivered. Right, it's almost like a slideshow. Now let's go to the Windows 8 case, launch the same video, and see what happens. I'll give him Okay, I'm going to pause it, right? So the experience, as you can see, is much, much better compared to that of Windows 7, primarily because, one, you have transport level optimizations that use UDP to deliver media content. And the other fact is feedback from the network system flows back to RemoteFX media streaming component. It's able to throttle or appropriately change its encoding rate so that content can be appropriately delivered in this network. Now, it's not just about media content, right? Let's launch a PDF document and then see what the experience is like. Right, what I'm going to do is quickly put this on auto scroll mode. Control Shift H does the trick. Right, so I've got two desktops side by side. One is Windows 7, the other is Windows 8. I've got the same PDF document in auto scroll mode. As you can see, Windows 7 is still struggling with the first page. On the other hand, the scrolling experience on the Windows 8 side is much faster and much smoother. If you had observed closely, you would see progressive rendering in action for the image part of the PDF document. Text always stays sharp. So this sort of demonstrates the graphics experience, right? Now let's look at how. Let me close this. Bye. What I'm going to do is I'm going to cut the rope so that we can demonstrate the interactive experience a little bit. I'm going to. By the way, both are still running in the same configuration. You've got a WAN emulator running in both cases. I'm going to click play here. The other one is still, the page is still rendering. I'm going to click play there as well. I'm going to go here. Let's go back here. Let's see, let's refresh the page. Okay, I'm going to close this demo so that we can move on to the next part. Okay, so we talked about WAN experience, right? The other aspect that I want to brief before we run out of time, I want to quickly talk about is the virtualized GPU experience. So far, all the demos didn't use a virtualized GPU. All we had was the in-box software GPU. Most applications were able to run fine. RemoteFX was able to deliver a very rich experience. But then there are always going to be classes of applications that require a virtualized GPU in them. Like for example, one example is, let's say you have an application that depends on GPU. Let's say it uses compute shaders for doing certain calculations. Those applications are always going to find it hard to run in an environment that doesn't have a GPU. That's where our RemoteFX virtual GPU comes in. So RemoteFX virtual GPU technology enables you to deploy a GPU on the server side and make a virtualized GPU available for the virtual machines that are running in the Hyper-V server. So that way, your virtual machines can now have a GPU, and your applications would be able to your DX applications would be able to make use of the GPU. We had the virtualized GPU technology in the Windows Server 2008 R2 SP1 release as well. However, it has been enhanced for this release. The virtual GPU now supports DX11. It's a DX11 compatible GPU. There have been other enhancements as well, including support for up to 8 monitors. That basically means your client-side device can have, if you have a 3D modeling application that requires multiple monitors, you can support up to 8 monitors. You could have a resolution of up to 1024 by, you can have a resolution of up to 2560 cross 1440. So that's the max resolution that is supported now with RemoteFX, with vGPU in Windows Server 2012. So let's see. So let me quickly show a demo of vGPU as well. So similar to the last demo, what I'm going to do is I'm going to launch 2 connections, one to a regular virtual desktop that uses the inbox software GPU. On the other side, I have a virtual machine that has a RemoteFX virtual GPU. So for those of you that are fans of DXDiag, let me quickly open that and show that on the one side, on the default software GPU side, you have the default what we call as the RDP UDT driver. which is not a WDDM device. On the other hand, on the virtual desktop with the RemoteFX vGPU, you could see that DXDiag shows me that I have a fully compliant WDDM 1.2 display driver. Now, what does that mean for applications? Right? So I've got a simple test application that is part of the SDK. This application is not very intensive in terms of graphics, but then it uses compute shaders to render a wave pattern. I'm going to launch the application both on the software GPU side as well as on the virtual GPU side. So one on the left side uses the default software GPU. The one on the right uses the RemoteFX virtual GPU. So let's give it a minute or so for it to compile. So this is supposed to be a wave-like pattern, right? So you can see the difference, right? So this is still, since this uses compute shaders, you don't have compute shaders on this side, so it is not able to compute the wave pattern as fast as the other side is able to do. The complexity is not so much in rendering itself, but it's in the compute shader aspect of it. Right? Okay, so we've got 5 more minutes. Let's quickly go to the next part. I'm going to skip through this, but basically, one of the complaints that we've often heard from customers is the fact that you're not able to run Link or similar VoIP applications in a remote session and have the same experience that users can have with their local desktops. RemoteFX in Windows 8 fixes that as well. It fixes that by, so before I go there, the problem basically was the additional latency that was introduced by having to go through the remote desktop side for audio video content, and then that being sent to the client that is either might be a Windows RT device or on a thin client. RemoteFX fixes that problem by enabling a direct redirection path between the user that you're talking to, that you're doing a VoIP call, and your remote desktop connection client. So what happens is your rest of link content, things like IM, app sharing, all control communication take the regular path, but then you have a direct path for link audio video between the remote user and your client. Like let's say I'm logged into a virtual desktop, I'm running Link in the remote session. Though Link is running in the remote session, if I were to place an audio video call, then the audio video data is directly communicated between the other user and my client. It doesn't have to go through the data center, get rendered there, and then remoted back. So this improves the experience, and then this matches the local experience that users have with Link audio video experience. I'm going to skip through that. So this is made possible by what we call as the RemoteFX media redirection APIs. This is not specific to Link. These APIs are public. There are 3 sets of APIs, one on the server side. So your VoIP application can call into that API and let RemoteFX know that this is my video region, track that for me. On the client side, your application, you could write a plugin for the remote desktop client. The plugin has to do is call the APIs on the client side and provide the video data. Client takes care of making sure that it knows where the geometry of the video window on the server side is. It gets the video content from your plugin, composes the final desktop frame, and then presents to the user. So there's very little that a VoIP application needs to do to integrate with that system. There are also dynamic virtual channels that have been part of RemoteFX that enables a full duplex communication between your component that is going to be running in the virtual desktop side versus the component that'll be a plug-in to the remote desktop application. There's documentation on MSDN, so you should be able to look up. Earlier I talked about how remote desktop and RemoteFX support being able to redirect to your local printers, your file system, your things like smart cards. So one of the things that RemoteFX supports is USB redirection. So RemoteFX can natively redirect any USB device that is plugged in on the client side. The redirection happens at the USB protocol level, so you don't need to have drivers as such on the client side. All your USB devices are made available to the remote session. So let's do a quick demo of that. I'm going to switch over to. So what I'm going to do is I'm going to connect to one of my servers. So Windows 8 also has what we call as the dynamic USB selection UI. So what I can do is once I'm connected to it, I can go ahead and select the devices that I want to be made available to the remote session. By the way, so before I select that, let me go to the control panel, and then I'm hitting refresh here, so that there's no device there's no USB device on the server side. But let me go ahead and select the devices that are plugged into the local client side. I'm going to say hit F5. It should appear here. Yep, you can see that I've got the Microsoft LiveCam device, which is plugged in on the client side, that is now available on the remote side. What I'm going to do is I'm going to show a quick demo to make sure that this works. I'll show a quick demo of the webcam device that I've added here. So I'll have to do a little bit of work here to get the video going. I don't have a video capture app running, so I'm going to be using GraphEdit. Okay, so I've got this, and then I also have another device here, right? So there's a USB missile launcher. Again, this is to demonstrate that you don't need drivers on the local side. It doesn't need to be a specific device that Microsoft produces. It could be any device, right? All you need is it needs to be USB 2.0 compliant, and it'll get redirected. So this nice little missile launcher that I got off eBay also comes with a control application, which is a Flash-based application. So what I'm going to do is, so I have this missile launcher application running in a remote machine. That's a session on a session node server that's back in my office. I'm going to be using the Flash application that is running in the data center to control the missile launcher. Right? Let's see. I'm going to go fire. Oh, yeah, it did fire. So just to clarify. So the app is running on the server side. The device is redirected through USB protocol to the server side. You can see that the webcam is working. The webcam is plugged in locally here. The session is running in a remote server back in my office. So the device is natively redirected. Okay, so let's switch back to the slide. So some of the key aspects, so you can use any device with USB redirection. Your users would be able to use devices. Your applications that are running in the data center will have access to these devices. The devices are redirected in a secure manner. The devices that a specific user redirects is only available for that user. Even an admin user on the server side would not be able to get access to the devices that a user has redirected. Now, so we talked about the demo. So I want to briefly touch upon the ecosystem for RemoteFX as well. So the RemoteFX ecosystem is pretty broad, right? So we produce the software, ship it as part of Windows. There's also a client that ships as part of Windows operating system. But then the ecosystem is much broader than that. You've got server vendors that are producing specific servers that have RemoteFX capable GPUs built in. Those server configurations are tested and certified for RemoteFX. You've got specific GPUs from the likes of NVIDIA and others that are certified for RemoteFX, which can support RemoteFX GPU virtualization. You've also got folks that are developing RemoteFX client software, be it for non-Windows platforms or for RemoteFX thin client devices, where customers just need to buy a zero client or a thin client device and then be able to use that with their centralized deployment with Windows 8. You also have semiconductor manufacturers that are producing chips that can do efficient decoding on the client side. Specifically for folks that want to develop thin clients, we also have what we call as the RemoteFX logo program. It's basically a mechanism to ensure that the clients meet the minimum requirements in terms of performance and compatibility. The implementations that qualify receive the RemoteFX certified stamp. There are a bunch of resources that are also made available as part of the logo program. You'll get access to the protocol documentation. You can also license the codec implementation if you want to go build a client. You also get access to some of the test tools that you can use to test your implementation against. I'm going to skip over the summary slide. We talked about the summary. A bunch of resources. You can start with the RemoteFX protocol documentation, which is on MSDN. All the RemoteFX DVC and media redirection APIs are also on MSDN. There's the RemoteFX logo program that I talked about. You can get in touch with me, and then I can reroute you to the appropriate person if you want to learn more about the logo program. We've got an excellent blog on the Remote Desktop Services team blog on our TechNet on blogs.msdn.com. It's an excellent resource. You can also reach out to us via comments in the blog. Yep, that pretty much summarizes what I want to talk about. We can now open up for Q&A. And thanks for being patient. Go ahead. Please use the mics so that that gets recorded. Go ahead.
Thanks, that was really good. On the USB redirection, how good does that work over a WAN?
So that's the excellent question, right? So it works very well over LAN, but then there are limitations in terms of what the actual devices. Certain device implementations are very chatty. So let's say you are on a WAN network connection which has, let's say, 200 milliseconds round trip latency, and your device implementation and the driver implementation expect a response of, let's say, a 10 millisecond response. Of course, the experience in that case is going to be suboptimal because your driver might time out because it didn't receive a response in 10 milliseconds. There's a certain bit of laws of physics involved in that case. I don't want to make a blanket statement. It depends on the specific device implementation.
So the best thing would be to test the device with like that network
latency
absolutely. Thing that you were having there.
Absolutely.
Okay, thank you.
Two questions.
Sure.
First one being, does RemoteFX support the Windows CE platform? Like, for example, could you put those two guys right there, the LifeCam and the rocket launcher, together as like one little deployable unit that would talk over Wi-Fi or something you could just stick somewhere and use Windows CE to power it and push RemoteFX through that?
So there are two ways to think about it, right? So the RemoteFX protocol and the server-side implementation is independent of what your client implementation is. All you need to do is have a device that is compliant with the RemoteFX protocol. Microsoft makes first-party clients available for the Windows 8 platform. We also released an update for Windows 7, both for Windows 7 and Windows 7 embedded SKUs. So for Windows CE, there is no client that we've made available, but then that doesn't limit a third party to build a client for that. In fact, we know that there are third-party implementations for a lot of different operating systems, including Linux, iOS, etc. Right? Okay. So there's no limitation as such, but we don't have a first-party client available for the CE platform.
Okay.
But if there's someone that is willing to do that, I haven't looked up recently, but maybe we should be able to look at probably there's someone else that has already built a client for CE.
Okay. And for the remote app experience, could that be used as a way to get the legacy x86 applications onto the Windows RT devices?
Oh yeah, absolutely, right. So the demos that I showed you, they'll work in the same manner on the Windows RT devices as well. So you could have any legacy application deployed in the data center, remotely delivered using RemoteFX to Windows RT devices.
Okay. Excellent, thank you.
You could have your applications running on Windows RT tomorrow using RemoteFX. Right?
It would be a quick question about the remote assistance. Is the remote assistance also have all this evolution on the graphical layer? Or
I'm sorry, can you repeat that question, please?
yeah, there is the remote assistance.
Remote assistance, okay.
Is the remote assistance also have the layer, all the graphical layer evolutions? Or
remote assistance is based on the RemoteFX technology, but then it doesn't use all the features that are part of RemoteFX. Maybe we can talk more in detail to understand what your specific requirements are and then see whether those are available for remote assistance. Yeah. Sure.
So my question is simple. Just to be clear, this is available now, right?
Yeah, this is available now. If you have a Windows 8 PC, you can remote into it and then see all this in action.
Okay.
Right? There's nothing else needed. You just need to enable remoting for that machine and then have it working.
Excellent.
Right. Cool, fantastic. So
Sorry.
Go ahead. Go ahead.
Follow up to that one. So in our environment, we'll probably be able to roll out 2012 pretty soon, but we'll have Windows 7 for quite a while. Will we be able to get any of these performance benefits in that mixed environment? So
we made an update available, in fact, last week, which enables all of the features that I talked about for Windows 7 as well. So though I showed a lot of performance comparisons between plain vanilla Windows 7 and Windows 8, once you have the update, the experience is going to be as good as Windows 8 on the Windows 7 desktop as well. It's an optional update that is on Windows Update on Download Center. If you go to the RDS blog, there's a blog post that provides you links to the update.
What about Windows desktops, though? Is that just for Windows 7 clients?
Both on the Windows 7 client side as well as the remote desktop side. So that's right, yeah. So basically, I mean, the RDP 8 protocol is available now for both the clients and the Windows 7 remote desktops. Go ahead. I'm sorry.
Is Windows Azure able to be used as a hosting platform for the remote desktop broker?
Today, if you have a Windows Azure based server instance, you can of course remote into it. But what I know is I'm not the most appropriate person to comment on it. There are certain licensing restrictions around how you can run remote desktop deployment, have licensed sessions, etc. It's not a technical limitation. It's a licensing limitation at this point. But feel free to talk to me after this. Probably I can give you more details. We can talk more about it. Right? I don't want to mislead you by giving an answer that yes, it does.
I knew it wasn't a straightforward answer.
Yeah, the engineering answer is pretty simple. It works, right? Because some of my demos, I was running it off of Azure.
That's a useful solution.
Yeah, useful. So that's where the tricky part is. But then, yeah, it's not a simple answer at this point.
Can this also apply to Windows Server? So from our RT device or from some other device, can we access some of the RSAT tools and stuff like that off of Windows Server?
RSAT, unfortunately, is not a remoting-based solution in the sense RSAT tools run locally. But if your question is, if I have Windows Server 2008 R2-based client, would I get all these benefits? Yes, you'll get these benefits with the new update that was released. On the virtual desktop side, you need to have Windows Server 2012. In fact, some of the demos that I did use Windows Server 2012 running in the data center side. So you could get the same experience. Thank you, everyone. Thank you. So I'll be here. Otherwise, I'll be in the STB booth outside in the blue area. So if you have questions, please feel free to come over. Thank you.